Okay, welcome to the video about converting equations. This is a really important video, but it draws on a lot of the algebraic skills we've been working on, and a lot of the things you already know how to do. We're just applying them in a new way and in a more sophisticated way. So, like I've been saying all along, we're using the skills that we have. We're hoping to increase our ability with those skills, but also increase the depth of understanding and apply these skills in new ways. So just to start out as review, standard form of a linear equation, you were introduced to this a couple days ago. Ax plus by is equal to c. We practice graphing that. We should feel comfortable with this. Okay? Slope-intercept form of a linear equation, this is the one we've been knowing and loving since middle school. Y is equal to mx plus b. M is the slope, b is the y-intercept. Okay, point slope form, we introduced this to you before the Thanksgiving break, and some people struggled a little with it, but some of us are feeling more comfortable. We're going to be practicing with this more. This is y subtract y1 equals m parentheses x subtract x1. So again, the m still is the slope, but the point x1 comma y1 is just a point. It's not necessarily the y-intercept. So it's a point on the line. All right, we're going to talk about converting now between different types of equations. So specifically, we're going to look at first, if you have something in standard form, ax plus by is equal to c, how do I convert that so it's in my slope-intercept form? There's many different reasons we might want to convert. One, maybe we want to find out what the slope is without graphing it. Maybe we want to graph it from this form. Maybe we want to find the y-intercept. Maybe we want to compare it to another line that's also in slope-intercept form. Okay, so lots of different reasons to convert. If we take this example here, 6x plus 5y is equal to negative 15. 6x plus 5y is equal to negative 15. All right. In order to get it into slope-intercept form, we want to have in the end the y all by itself and everything else over here. Something with the x, that's going to be our slope, and then some y-intercept at the end here. Well, right now, the y has a 5 that's being multiplied by it, and this 6x that's being added to it. Just like when you're solving equations, you're going to do opposite operations to get the y by itself. So if I want to move this 6x out of the way over to the other side of the equal sign, it's a positive 6x right here. I'm just going to subtract 6x. If you like to draw the line down when you're solving equations, you might want to draw that here. And I'm going to do subtract 6x on this side. Now, here's where you need to be very careful. Obviously, the 6x's cancel each other out here. I'm just left with 5y on this side. I'm doing pretty good. I'm getting closer to just having the y on this side. On the right-hand side of the equal sign now, I have a negative 15 and a negative 6x. This negative 15 does not have an x with it. This negative 6 has an x with it. I cannot combine them. They are not like terms. So all I can do is just list them next to each other. I like to list the term with the x first because that's how we're used to seeing the term with the x first. But if you list the 15 first, that's fine as well. Just make sure it's, the other option would be to say 5y is equal to negative 15 minus 6x. If you write it that way, that's fine. The y is almost by itself, but it's being multiplied by 5. The opposite of multiplying by 5 is dividing by 5. So I'm going to divide by 5 and divide by 5. That gets the y totally by itself here. Now I have to apply the 5 to both terms. So I have to do, I'll just write it here, negative 6x divided by 5, and negative 15 divided by 5. Well, negative 6 divided by 5, I can't reduce that fraction. I could make it 1 and 1/6, but typically we leave it as an improper fraction for the slope because we could do down 6 and over 5 for the rise over run. So I'm just going to write it in, negative 6 over 5. If I could have reduced it, I would have wanted to. This part, I can reduce. 15 divided by 5 is 3. So I just do negative 3. And so here is my slope-intercept form of my standard form equation. Just to finish up, if you were doing it this way with the 15 first and the 6 second, y is equal to, it would just be negative 3 minus 6 over 5x this way. Just the order is switched. Okay, let's look at another example. Here we have 13x minus 9y is equal to negative 12. I want to get the y by itself, so I need to move the x part away. Since I'm bringing it to the other side of the equal sign, I'm going to subtract it. 13x minus 13x. Maybe we like the line here. I'm sorry, that thing keeps popping up. The x's cancel. Negative 9y is equal to negative 13x minus 12. Again, I cannot combine them. One has an x, one doesn't. Can't combine them. Get the y by itself, divide by 9. Divide by 9. Y is equal to, again, the 9 has to go to both parts here. 13 divided by 9, I can't reduce. I'm just going to leave it as negative 13 ninths x. 12 divided by 9, 12 over 9, 3 goes into both of those, so 3 goes into 12 4 times, and 3 goes into 9 3 times. So I do want to reduce that when I can. So there's my y-intercept, there's my slope. So same thing, if we jotted down a few rules or steps here, okay? Step 1, move the x by either adding or subtracting, right? Opposite operations. And then step 2, divide by the coefficient of y value. The coefficient is the number in front of y. And we need to then reduce, if we have anything to reduce. Let's take a look at this example. We're going to start by subtracting 3x minus 3x. Negative 2y is equal to negative 3x subtract 8. Divide by negative 2. Divide by negative 2. Have to keep the negative with the 2. That's really important until we divide by negative 2. Negative 3 divided by negative 2. Can't do anything with the 3 and the 2, but I can do something with the negative and the negative. So I'm just going to have 3 halves x. Negative 8 divided by negative 2. Well, that's a positive 4, so that reduces nicely into that nice slope-intercept form. Here's this one here. I think I have 2 more examples. Okay, remember, if there's no coefficient in front of a value, it's a 1, so feel free to add a 1 in if you want. Same steps though. Minus 4x, minus 4, oh boy, I'm sorry. I don't know what's happening here. Hold on. Let's just clean this up for a second. Okay, let's try again. Sorry about that. There's a little pause for you. Okay, I want to bring the 4x over to the other side, so I'm going to subtract 4x from both sides. Subtract 4x. X's cancel. Negative 1y is equal to negative 4x plus 1. Cannot leave a negative 1 with the y, so we need to divide by negative 1. Y is equal to negative 4 divided by negative 1 is positive 4. X, 1 divided by negative 1 is negative 1. So there is my slope-intercept form. Last example, draw the line. If we'd like to draw the line, we're going to subtract 6x. Subtract 6x. The x's cancel. 5y is equal to negative 6x. Subtract 15. Divide by 5. 5's cancel. Y is equal to, same one we just did, negative 6x over 5 minus 3. I'm sorry, we just did that example, but now you know it again. Alright, here is where we're starting with some information, but we want to get it into standard form. This should look familiar. A line passing through a point, 1, 2. That sounds like that might be our x1, y1, and our slope, our m, is 7. Well, if you have the slope and a point, you should be saying we want to use point-slope form. So look back at your first page, or you can remember that's y minus y1 equals m times x minus x1. I'm just going to grab a different color here. If we want to fill in the parts that we know, then we're going to fill in the slope is 7. X is just x. My x1 is 1. Y is just y, and my y1 is 2. So here it is in point-slope form. I want to get it into standard form. Well, the way you're going to do that is you're going to convert point-slope form into slope-intercept form. And you, INTERC, slope-intercept form. That's the y equals mx plus b form. You've been doing this. You know how to do this. The first step is to multiply, so that's going to be 7x. And 7 times negative 1 is negative 7. We still have the y minus 2 on this side. We're going to add 2 to the other number without an x. We wouldn't add it to the one with an x because remember they're not like terms. So now we have y is equal to 7x minus 5. Well, if I want it in standard form, then I want to put it so that the ax is first, the by is second, and then the c. So we're going to move the 7x over to the other side. Again, when you're switching sides of the equal sign, you need to use opposite operations. So we're going to subtract 7x from both sides. Minus 7x plus y is equal to negative 5. Ax, there's my by. My b in this case happens to just be a 1. That's okay. And there's my c term, just the number all by itself on the other side. Whew. That's a long process, but it's not impossible. Alright, a line passes through negative 2, 5 with a slope of negative 4. So again, we're going to start with our point-slope form because we have information that gets filled in easily in point-slope form. So if my slope is negative 4, my x1 is negative 2, so I'm subtracting a negative 2. Be very careful with your negatives. My y is a 5. So this subtracting the negative becomes positive. I'm going to do the distributive property with negative 4. So I have y subtract 5 is equal to negative 4 x subtract 8. I'm going to add 5 on both sides. Y is equal to negative 4x minus 3. So here we're in point slope. Here we're in slope intercept. Now we need to get into standard form. So to do that, I just need to add 4x to both sides. Remember, we want an x term, a y term, and a c term. So don't be combining the x and the y to make this 5xy or something silly like that, right? This has an x, this has a y. Cannot combine them. They are not like terms. Here we are in standard form. Okay. Same thing again. Y minus y1 equals m times x minus x1. You should be becoming an expert at this. Fill in my slope. In this case is 5/3. Don't freak out that it's a fraction. It's just a number. X subtract 3. Y subtract 5 from my x1, y1. Distributive property. That's going to be 5/3 x. Now, 5/3 times -3, the easiest way to think about this is 5 times -3 is -15. 3 times, if this is over 1, is -15. 3. -15 over 3 is just -5. And we have y subtract 5 here. To get the a term over in front here, oh, sorry. First we have to add 5. Those cancel. Y is equal to 5/3 x plus 0. That's fine. You can have 0 as a y-intercept. So here we are in point slope. Here we are in y and oh boy, I'm losing it. Slope intercept. Now we want to get it into standard. So I need to add 5/3 x over in front. 5/3 x. So we have 5/3 x plus y is equal to 0. Now there's one last thing. To be very precise about standard form, we're not going to allow any fractions. So the way to get rid of fractions is to multiply by the denominator. So if I multiply all of these terms by 3, 5/3 times 3 is going to leave me with just 5x. And that's what I want. I want to have no fraction as my first term. 3 times y is 3y. Have to multiply all 3 terms if I multiply one of the terms. In this case, 3 times 0 is still just 0. So here's my final standard form equation. So here's one little star idea. No, do not leave fractions. So make sure you get rid of the fractions. I think there's one more example. You've done a great job. Here we have a line that passes through 3, -1, so it looks like we have a point, and it says it's parallel to y equals -x plus 4. Well, the fact that something is parallel means we need to know that parallel lines have the same slope. So the slope of this line is -1. So we're going to use that as the slope here. So y subtract y1, m times x subtract x1. So we have y subtract -1 becomes +1. Our slope is -1, x subtract 3. Distributive property, y plus 1 is equal to -1x plus 3. We're going to minus 1 to get the y by itself. -1x plus 2. Add 1x to the other side. So 1x, or you could say just x, plus 1y, or you could say just y is equal to 2. So 2 versions here of standard form. You can include the coefficient of 1 or not. Good luck. Like always, we'll be practicing this in class.